Okay, this is another method that you can use to rotate an object. I think this method, which I call the counting method, is a lot easier than using a protractor and a compass. But it does have one shortcoming, and that is that this method will only work if the angle of rotation is a multiple of 90 degrees. That is, if the angle of rotation is 90 or 180 or 270. Now on the CSEC exam, I believe the angle of rotation is always going to be a multiple of 90 degrees. So this method will serve you well on the exam. But if you have a different rotation for whatever reason, like a 60-degree rotation or a 45-degree rotation, then this method won't work for you anymore. But okay, we'll talk about this method, the counting method. Here I've got a triangle ABC, and I want to rotate it 90 degrees clockwise about the origin, using the origin as the center. Draw its image, triangle A prime, B prime, C prime. Okay, so basically this is how it works. You'll recall that before what we would do is we would draw a line segment. I'm going to kind of do this again right here, and I want to give it a different color so that we can see. I would start by rotating A, and I'd want to draw a line segment here, and then the idea would be to sort of rotate that line segment 90 degrees clockwise, which would mean to rotate it over here, right? Because the clock would turn this way, 90 degrees this way. To create A prime, and we'd use our protractor and compasses and all of that. But there's another method that you can do that just involves kind of simple counting. I noticed that to get from A to O, if I break that down into up-down distances and left-right distances, I can see that to get from A to O, I need to go down by 1 and over by 2. So 1 and 2 are the key numbers here. Now I know I want A prime to be over here somewhere, which means if I do that same sort of count, if I do a count of 1 and 2, I'll kind of be able to tell where A prime should go. Now there's actually two ways that you can count over here with a 1 and a 2. I could go 1 to the right and 2 up. That's one possibility. 1 to the right and 2 up. Another possibility is I could go 2 to the right and 1 up. So I know that one of these 2 points has to be my A prime. Now what I do to figure out which one really works is, if I look at this line right here, if I draw this line, I can see that that angle appears to be more than 90 degrees. So I don't think this point here is going to work very well. So I'm going to go ahead and delete that because it does not form a 90-degree angle. But if I draw this line, that is a 90-degree angle. Okay, so therefore I know this has to be my A prime point. So let me label it as A prime. Okay. Because I know that the length of this and this are the same. My counting ensured that that would happen. That's why I did the count. And then I can see that this angle formed is 90 degrees clockwise, which is what I wanted. So A prime goes right there. Okay, now I'm going to do this counting trick with B. So if I draw a line from B to O, and then I count, how do I get from B to O going up, down, left, right? So to get from B to O, it looks like I go down by 2 and over by 1, 2, 3, 4, 5, 6. So the numbers here are 2 and 6. And again, there's only two ways that you can do those numbers over in this area. I can go 2, 3, 4, 5, 6, or I could go 6 and 2. Okay? Now again, only one of these points is going to work, and it's pretty easy to eliminate in this case the one that doesn't work. Again, this line clearly doesn't form a 90-degree angle. That's obviously an obtuse angle, so it cannot be this one. So I will go ahead and erase this one. It can't be this point. Has to be the other point, but I'll still confirm it. If I draw this line segment, yes, I can see the 90-degree angle, so therefore I know that this is my point, B prime. And then finally I'll do my little counting trick for C, and then I'll be finished. So if I want to move from C to the origin, the count would be 3 down and 1 over. So my count is 3 and 1, so I could either do that as 1, 2, 3, and 1 like that, or I could do it as 1 and 1, 2, 3 like that. Okay, there's only two ways that I can count the numbers 1 and 3 over in this quadrant. Now, again, obviously this one is no good because that angle is less than 90 degrees. It can't be this point, so I will delete that. It must be this point, but I'll still confirm. If I draw that line segment, sure enough, there's your 90-degree angle that we were looking for. So this becomes the point C prime. Okay, so I've got my 3 points. Now all I have to do is connect A prime, B prime, and C prime, and I will have completed the rotation. So the rotated triangle looks like this. Always a good idea to just do the eyeball test to make sure it works. The 2 triangles should be congruent to each other, which they are. It's just that this has been turned. I can see that they have the same shape and size, so this is a successful rotation.